All right, for number one here, we are just looking at factoring. So I notice that that's a difference of squares. Now remember, the first step to factoring is to always look for greatest common factor first. There isn't one here. So when we go to factor this down, this would be just 3y plus 4 times 3y minus 4. Now this next one, again, your first step is to always look for so on number two here, you always want to look for a greatest common factor, but there isn't one. So the next thing I'm going to do is I'm going to multiply together, because our a value is not 1, so we can't just look to see what two numbers multiply together to be 16 that add together to be negative 24. That does not work. Instead, we multiply the first and last terms together. When you do that, you get 144z squared, and the middle term is negative 24z. So now I'm trying to find two numbers that multiply together to be 144 that add together to be negative 24. Well, that's negative 12z and negative 12z. So when you multiply those together, we get a positive 144z squared. When you add those, you get a negative 24z. So now what I'm going to do is I'm going to take that and I'm going to rewrite it. But in the middle, I'm going to write down those two terms. So minus 12z, and then plus 16. Then remember we factor this by grouping. So I group together the first two terms and last two terms. So I see that for the first two terms, I can factor out a 3z. When I do that, I'm left with 3z minus 4. Now remember, no matter what, even if I can't factor anything out, I always write a sign out here, and that sign is going to be whatever I circled there. So if it's a plus, I put a plus. If it's a minus, I'm going to write a minus, so it's going to be a minus here. And then between 12 and 16, the greatest common factor is 4. So I'd have a negative 4. So negative 12 divided by negative 4, that's a positive 3z. And 16 divided by negative 4 is a negative 4, so that's important. Because now we have the same thing in parentheses, 3z minus 4, so that would be one of the factors. The other factor is what's left over, which is also 3z minus 4. So if you wrote it like that, or you could write it as 3z minus 4 quantity squared. All right, let's look at number 3. Number 3, this is one of those that are a little bit easier. We can just look to see what two numbers multiply together to be 30 that add together to be a negative 11, and that's negative 5 and negative 6. All right, number 4, remember your first step is to always look for greatest common factor. There is none. So then what we're going to do is we're just going to take and focus on the first term and the last term. We're going to multiply those together. So when I multiply those together, we get 120x squared. And the middle term is 23x. So I'm trying to find two numbers that multiply together to be 120, that add together to be 23. It might take you a little bit of time to find these, but it's 8 and 15. So it's going to be 8x and 15x. So what we're going to do is we're going to rewrite this equation, but this time in the middle, we're going to put that 8x and 15x. All right, so now we're going to factor this by grouping. So we're going to group together the first two terms and the last two terms. So from those first two terms, we see that we can factor out a 2x. And again, since this is positive, I'm going to put a plus there. Between those last two terms, we can factor out a 3. So what's in parentheses is the same, so that's one of the factors, 5x plus 4. What's outside of the parentheses, we have 2x plus 3 done as the other factor. All right, so for number 5, again, your first step is always look for greatest common factor. Now, although 4, 20, and 25, you don't have a number that we could factor out, I do see that they all have at least a y. So I'm going to factor out a y. So we'd have 4y squared minus 20y plus 25. Now I'm going to focus on just that piece, the 4, 20, and 25. And so I know if you did the previous two problems that we're going to have two values here in the middle because, so I'm just going to do this a slightly different way, so a little bit less work. But we're looking for what two values we'd have in the middle here. So if I multiply together the 4y squared and 25, I'd have 100y squared. So we're trying to figure out what two numbers multiply together to be 100 that add together to be negative 20. Well, that's going to be negative 10y and negative 10y. So that's what will go in the middle. And now we'd factor this by grouping. So from the first two terms, I see that I can factor out a 2y. so leaving us with 2y minus 5. For the last two terms, again, we have a minus here, so that's got to be a minus. I see those are both divisible by 5, so we'd have a negative 5. And negative 10 divided by negative 5 is a positive 2, so we'd have 2y. And 25 divided by negative 5 is negative 5. So this one, we'd have 2y minus 5 in parentheses and 2y minus 5 outside of parentheses. Or we could write this as 2y minus 5 in parentheses squared. Either of those would be the correct answer. The last one's already set up as a set of 4 terms, so we're just going to solve this one by factoring. So from the first 2 terms there, we see we can factor out an x squared, leaving us with 2x minus 3. And for the last set, remember we always at least factor out a plus, and I don't need to change anything. I don't have a greatest common factor there, so that's going to stay 2x minus 3. So what's in parentheses is 2x minus 3. What's outside of parentheses is x squared plus 1. That can't factor anymore, so that would be your final answer for number 6. All right, number 7. We're going to find an equation of a line passing through those 2 points. So the first step is to figure out, well, what's the slope? So if I do 6, so if I subtract the y's, 6 minus negative 3 becomes 6 plus 3. If I subtract the x's, negative 2 minus 1 would go on the bottom. So 6 plus 3 is 9, negative 2 minus 1 is negative 3. When I simplify that, I get negative 3. So my slope is negative 3. Now it says to write our answer in point slope form. So remember, point slope form is this: y minus y1 equals m times x minus x1. And we can use either coordinate for your x1 and y1. So technically there'd be 2 possible answers here. So I'll write down both of them, but you only need one. So let's say if I use the first coordinate, it would be y minus negative 3 becomes y plus 3 equals my slope, which is negative 3, times x minus my x1, so that'd be 1. Or we could use the other coordinate. So we have y minus 6 equals my slope, which is negative 3, times x plus 2. Now it says to leave it in point slope form, but if we did simplify these and got them in slope intercept form, they both look identical at that point. All right, this one's a little trickier. It says, again, write your equation in slope form, or I'm sorry, point slope form, not slope intercept form, point slope form. And it's going to go through the point 10, negative 3, and has a graph that is perpendicular to the graph of y equals 5x minus 2. All right, so here's why they give us this. We could find the slope of the line by using that equation. Now the slope for this one is 5. But that's not what we're looking for. We want to find the equation of the line whose graph is perpendicular to that. So what we're going to do is we're going to take the negative reciprocal of 5. The negative reciprocal of 5 is negative 1/5. So that's the slope I want to use, negative 1/5. And the formula it's going to be in is y minus y1 equals my slope times x minus x1. So now we're going to plug in everything we know. So we have that coordinate, 10, negative 3, and we have our slope. So it'll be y minus the y value, so y minus negative 3 becomes y plus 3. My slope, negative 1/5, times x minus the x value, so x minus 10. And that would be your equation for that particular line. All right, so this one, it says write an equation for the linear function satisfying these conditions. So what this is saying is that when we put negative 3 in for x, we get negative 2 as our answer for y. So that's, in essence, giving us a coordinate, negative 3, negative 2. And this is giving us a coordinate. When we put 4 in the function, we get negative 9 as our answer for y. So that's giving us our second coordinate. This one, they do say we want it in slope intercept form. So first, we need to find the slope. So if I subtract the y values, it'll be negative 9 minus negative 2, so negative 9 plus 2. 4 minus negative 3 become 4 plus 3. Negative 9 plus 2 is negative 7. 4 plus 3 is 7. So we have a slope of negative 1. Now we can use either coordinate. It doesn't matter which one. I'll just use the first one. So it'll be y minus negative 2, so y plus 2, equals my slope of negative 1 times x minus the x value, x plus 3. Or we can distribute that slope through now. It would be negative x minus 3. Again, we're trying to get this in slope intercept form, so that's why I'm doing this extra work. So now to get it in slope intercept form, we just want to get the y by itself. So I subtract 2 from both sides. When I do that, I get negative x minus 5. So that would be our equation in slope intercept form. So that's how you would do those problems from chapter 1, or actually chapter P.